Alright, so here we have the guided notes for factoring. In the last video we ended with foiling, and I want to just repeat this pattern because patterns repeat. So this pattern of things that we do forwards in math, we're going to try and do backwards. So if foiling is forwards, then factoring trinomials would be backwards. So the way I think about factoring these trinomials is the deconstruction of FOIL, and we're going to work that outside in. And I kind of like you peel an onion. So starting with F and L, we're going to find the factors of F and L, and then go towards the OI. So the method that I use is what's called guess and check. And the guess and check method, it's simply put, we're going to start and we're going to find the factors of F and find the factors of L first. And then we're going to deconstruct the OI. So the helpful hint written here is that we're going to try using the factors that are closest together. Closest together first. And that's usually the way these work. Alright, so once we find the factors of F and L, we're going to check to see if O and I will work. And what I mean by that is here, factoring this trinomial, x squared plus 8x plus 15. So here's our F, here's our L, and the OI create the single term in the middle. So the factors of x squared are x and x. See, we handled our F. And the factors of 15 that are closest together would be 3 and 5. Now here's what I say whenever I say guess. I mean, just put them in there. Take the closest factors of 15 and put those in as your L. And the factors of x squared, x, and x. Now we're going to check. And we do this by checking the outside, this guy times this guy. And we say x times 5 is 5x. And then we check the I, the inside. And 3 times x we know to be 3x. And we add these together. When we combine 3x and 5x, clearly we get 8x. So I could tell you for sure that x plus 3 times x plus 5 are the factors of x squared plus 8x plus 15. Now here's one of the, this is what I call the second sign rule. And the second sign being this sign here, the second sign of the trinomial. So the second sign of a factorable trinomial, so if the second sign of a factorable trinomial is positive, then the signs of the binomial factors will be the same. The same. If the second sign of the factorable trinomial is negative, then the signs of the binomial factors will be different. So here, let's try this one out. X squared minus 2x minus 63. Well, first we got to find the factors of x squared. Well, the factors of x squared are x and x. And the factors of 63, well, it's 1 and 63. And this is how I want you to factor the L term. 1 and 63. 2, we will just count from 1. And 2, does 2 go into 63? No, 63 is odd. Does 3? Yeah, 3 goes into 63 21 times. What about 4? Does 4 go into 63? I don't think so. 5 clearly doesn't because 3 is neither 5 or 0. And 6, does 6 go into 63? It does not. I know that because I have a calculator. But 7 clearly goes into 63, and the other factor of that would be 9. And I know for sure that 8 does not. And now look, I don't need to keep going because 9 would be the next number, and I already know that's 7, and if I count all the other numbers in between, I definitely won't get there. So it's just as simple as counting to 7. I can name all the factors of 63. Now, starting with the factors that are closest together, I'm going to go ahead and put together my binomials here. So here's my factors of f. We put here, and I have an x and an x. And now my factors of 63 for my L, I have 7 and 9. Now, since my second sign is subtraction, then I know that I have different signs. So I'm just going to go ahead and try them out. I'm going to try negative and positive. And then I can check by doing my outside. X times 9x is a positive 9x. And negative 7 times x, this is a negative 7x. And when I combine these, I get a positive 2x. Oh, I wanted a negative 2x. So I know that these aren't the right signs. So I can erase this here. And, go ahead and erase that. And I'm going to try the other way. So I'm going to say this one's positive and this one's negative. And check my outsides. And x times negative 9 is a negative 9x. And a positive 7 and an x is a positive 7x. And when I combine those, I get negative 2x. That's what I was looking for. So now I know for sure that x plus 7 and x minus 9 are the factors of x squared minus 2x minus 63. Now, the difference of perfect squares. Let's take a look at the difference of perfect squares. This is a special case of factoring. It's a very particular pattern that we have found. And the way I like to introduce this is, let's take a look at what it means to FOIL forward when we look at these. Now I took just randomly x plus 2, x minus 2. Now when we FOIL this out, we get x squared minus 2x plus 2x, and 2 times negative 2 is minus 4. Now when we combine like terms, I start with x squared and negative 2x and positive 2. Well, those cancel each other out, and I'm left with x squared minus 4. So I have no middle term here. It's pretty interesting. So my question is, since I have no middle term, what happened? First of all, what happened? Well, there's no middle term. And then my question is, does that always happen? With an emphasis on the word always. Because whenever something always happens in mathematics, then we can rely on that to be a truth. And so the one way we could test that out is to just do random letters. Say a plus b, a minus b, right? Just like we did x plus 2, x minus 2. Here I'm going to do a plus b, a minus b, and see, does that middle term always cancel out? Well, I could FOIL this here. And a times a is a squared. And a times negative b is minus a b. And b times a is a positive b a, and b times negative b is a negative b squared. Well, Mr. Stevens, now look, this is a negative a times b, and this is positive b times a. But since we know the commutative property of multiplication, this is the same thing as a positive a b. Well, a negative AB and a positive AB, well, that's going to cancel out. So this all goes to 0. And I have a squared negative b squared, so I'm left with a squared minus b squared. And that's FOILing, which is forward. Now, I can make a general rule here. For the difference of perfect squares, if I have a perfect square and a binomial where the first term is a perfect square, and we are subtracting another perfect square, then it will always be the case that we are left with a plus b times a minus b. All right, the square root of the first term plus the square root of the second term times the difference of those. And let's try a few out and see if we can figure this out. So I want you to do these on your own first. So this is another opportunity for you to pause and try these problems out. And hopefully you got the right answer there. So the square root of x squared is simply x, and the square root of 4 is 2, so it's going to be x plus 2, and I'm going to multiply that x minus 2. Now we saw that problem already, so that's kind of cheating. But here this one's a little bit different. Here the square root of y squared is going to be y, so I have y, and the square root of 144 is 12. So I'm going to have y plus 12 times y minus 12. Well, hopefully you got those. And let's go to the next page. I'm going to give you a second to try these out. Now here we're looking at the square root of 25 is 5, plus the square root of b squared is b, times 5 minus b. And here's my factors for that binomial. And this guy here, hey, wait a second, that's not like the other ones here. This is the sum of perfect squares, and for that it will always be prime.